Alrighty, we are taking a look at section 5.4, where we're looking at inverse functions again, but more specifically between the exponential and logarithmic functions. So they're going to be sharing some of the same properties where we are switching the domain and range, we're switching points. So in this specific part here, from the function, the 0.13, on the inverse it would be 3,1, and so on for the rest of those points. And then just like what we did before, we're switching the domain and range. And so the domain here is negative infinity to infinity, and my range is from 0 to infinity. So we'll see that those will flip, as well as the graph is going to flip over the graph y equal to x. Also, if you could just take one of these points, it's very easy to say, okay, where is a point 3, 1? And we can see that only this graph has that point on there. Just like I said, the inverses have the range of the original function, and that's what the domain is, and the range is the domain of the original function. And as you can see, this graph increases. And if we see that whatever the domain is, that will be helpful for the equation for the vertical asymptote. Same thing going on here. Best thing is to just pick one point and then do the inverse point. So if we just choose this point here, which is negative 1, 3, then I should have a point 3, negative 1. So that's an easy way to kind of go through that. Same thing here, just kind of choose one point here. I got this point here, 1, 7, so I should have the point 7, 1 on here. And as you can see, we have some correspondence between the domain and those vertical asymptotes. Now, when we're looking for domain here analytically, we're just setting this kind of equal to 0 but greater than 0. Because we simply can't get a negative number here. That doesn't exist. And so it's just like we can't take any number to a power and get a negative number. So it's the same thing happening here. So I simply solve, and then I can see that I can put in any number that is greater than negative 1/9. And this will follow suit for the rest of these. Greater than 0 here. This should be greater than 0. We have all real numbers here because we get imaginary numbers when we take the square root of a negative number. And then here we kind of make a chart. So same thing here, which is greater than this. You can, we can just kind of plug in numbers. So I made a little chart here so I know that negative 9 and 9 are the zeros. And so I just kind of plug in some values. So if I plug in negative 10 here, I end up getting a negative number. And we can't have that. If I put in 0 here, 0 is a number in between here. If I put in 0, I get 81, which is positive, so I can use that. And if I put in 10, I also get a negative number. So that lets me know that where the positive numbers are, that is where my domain is. So I know my domain is between negative 9 and 9. We will continue that for the rest of these. So we're just trying to find the zeros. So here we could factor, or you could use the quadratic formula. All up to you. And then we see that those zeros are indeed negative 6 and 9. I plug in numbers to see what gives me a negative in there. So I'm just plugging it into here. So if I plug in, let's just say negative 10 into here, I end up with a positive number. If I plug in a number in between here, like 0, I get a negative number. And if I plug in a number like 10 out here, I end up with a positive number. And therefore, I know my domain reflects that, where the positive numbers are. Same thing here. So we have a cube here, so we know we should have 3 different zeros. Sorry, it's negative 4, 0, and 4. So I do that same process. I plug in a negative number like negative 5, plug in negative 2, plug in positive 2, plug in positive 5. And I see that my domain is between negative 4 and 0 and 4 to infinity. And moving on to the next problem, we're just graphing here. So we have an exponential function with a base of e, and we have a vertical shift of 2. We have here. Here we have a logarithmic here with a horizontal shift of negative 1. So we see that going on here. Here we have a logarithmic graph, base 4. So we have the basic shape here we can see here. Here, if we need me to do one live of this, I will, but this is basically what happened. We have a base of 1/2. Make sure you are choosing a logarithmic tool. We have a y-axis reflection because the x is negative. And we have a horizontal shift of a positive 8, because if we put 8 in here, we would get 0. The next one, we have to make sure our base is 2. This is indeed a logarithmic function. And we have a horizontal shift of a positive 1. Here, we looked at this before, where we have We can write this as an exponential function. So 4 to the x, we don't know, is equal to 8. And then we have to write these in base 2. And we can set the exponents equal to each other. So in this one here, we are graphing both the function and its inverse. So same thing with our inverses. We switch the x and the y. And we solve for y. That's what we get here. That is our new inverse function. And then we just graph both of these. So here we can see we have base 4, and we have a vertical shift of -6. And that's what happens here with this function. And then you just simply choose logarithm, and you'll then put in base 4, and we have a horizontal shift of -6 for this function. So you have both of them on there. And then for our last one here, we're finding where these things intersect. So you're going to be graphing x minus 2 and this logarithmic function, and we're seeing where they intersect, and I will post a separate video.